Hello everyone, this is SREE, Maths faculty in Talla Padmavathi International School. Today, let us see the chapter Rational Numbers of Class 7. So children, before rational numbers, you have learnt natural numbers, whole numbers, integers, okay, and also even fractions. So before going to rational numbers, let us see what are fractions. You already know children, fractions are the numbers which are in the form of P by Q, where P and Q are whole numbers and Q is not equal to 0. Q should not be equal to 0. Example you can see here 3 by 4, 5 by 6, 7 by 8 and so on. Okay, these are fractions. Then what are rational numbers? Just see what are rational numbers children over here. Rational numbers means the numbers which will be in the form of P by Q. The numbers which are in the form of P by Q, where P and Q are children. Here it is whole numbers. Here they are integers. P and Q are integers, where Q should not be equal to 0 and Q should not be equal to 0. Other than 0, it can be any other number. Example now you can take. So integers means you will be having negative numbers, positive numbers along with a 0. Right children? So you can have minus 1 by 2, okay, 3 by minus 4 or 5 by 6. Integers means both you can have even the positive integers also, and you can have minus 7 by 8 and so on. Okay, so the difference is in the fractions we are going to take P and Q as only as whole numbers, where the positive numbers and 0 is involved. But whereas in the rational numbers we are taking integers, means you will be having positive numbers, negative numbers along with a 0. Now let us see equivalent rational numbers. What are equivalent rational numbers? We have seen equivalent fractions, right children? Like that we have even equivalent rational numbers. So for that let us take a rational number, that is minus 7 by 2. So this is a rational number which I have to. So what are the equivalent rational numbers for minus 7 by 2? So nothing children, it's very easy. You take a number. Suppose here I am choosing a number as 2 children. Here I am choosing a number 2. So with this is the numerator and this is the denominator. So just take the numerator and denominator, and as you have 2 here, you need to multiply the 2 to the numerator and also to the denominator. Okay, now just multiply them. Minus 7 into 2 is what? Minus 14 by 2 into 2 is 4. So children, here you can say that minus 7 by 2 is equivalent to minus 14 by 4. Now let us take one more number, that is 3. Again you want to make one more equivalent fraction, one more equivalent rational number. So for that what you will be doing? The same method again. You need to take the number and you need to multiply to the numerator as well as to the denominator. So just see minus 7 into 3 by 2 into 3. So 3 I multiply to the numerator and as well as to the denominator. So minus 21 by 6. So therefore, like that you can get infinite equivalent rational numbers for this. Okay, there is no limit for that. So just see here minus 7 by 2 is equals to minus 14 by 4. That is equals to minus 21 by 6. Yes children, these all we can say that they are equivalent rational numbers. Now let us see positive rational numbers and negative rational numbers. So what are positive rational numbers children? Yes. So when when a numerator and denominator both are negative integers, or when both are positive integers, you can say that such rational numbers are positive rational numbers. Suppose, let us see here children, let me take a number that is 3 by 4. So just see here, it is a positive integer and here also it is a positive integer. So both the numerator and denominator are positive integers. So you can say that this is a positive rational number. Now let me take one more number that is -7 by -4. So just if you observe here, the numerator and denominator both are negative integers. So here also we can say that this is a positive rational number. Why? Because here negative number and negative here get cancelled. Again you will be getting 7 by 4. So we can say that the numerator and denominator both are positive, then it is a positive rational number. Or if both are negative integers, then also we can say that they are positive rational number. Okay. Next, coming to the negative rational number. Take a rational number like I have to -7 by 4. So -7 by 4 means you can say that this is a negative rational number. So here it's very clear. If numerator or denominator, if any one of the numerator is negative, then negative integer, then you can say that it is a negative rational number. Suppose here I am going to take 8 by -5. So children, here if you see, the denominator is a negative integer, then you can say that it is a negative rational number. Any one of them, either this or this, any one should be negative integer, then we can say that they are negative rational numbers. Now let us see the rational numbers on number line. So children, we have represented the integers on number line. How we used to represent the integers on the number line? Just we used to draw a line and we used to mark a point as O in the middle of the line, that is 0. And to the right side of the 0 are positive integers, and to the left side of the 0 we used to represent negative integers. So just see here 1, 2, 3, 4, right side, and left side -1, -2, -3 and -2. So in the same way children, here positive rational numbers are represented towards the right side of the 0 and negative rational numbers are represented towards the left side of the 0. So just let us represent -1 by 2 on the number line. So for that what you have to do is children, you need to draw a line as it is like integers. You need to take a point in the middle of the line, say it as O, and that will be 0. So now towards the right side take 1. So children, there is an important thing here. If you observe the denominator is 2. So from 0 to 1 we need to make 2 equal parts. So just see here 2 equal parts. Then this becomes 1 by 2. This becomes 1 by 2. Next children, again from 1 to 2, again you will be having 2 parts. So just see here 1, 2. So it is 1 by 2 and this will be 2 by 2 and this will be 3 by 2. This will be 4 by 2 and so on. So if you will take 3 also in between them, you will be having 2 parts. 1, 2. So this becomes 5 by 2 and so on. It goes on. Now towards the left side of the 0, we are going to represent the negative rational numbers. So see here children, suppose if this is -1, again from 0 to -1, we need to make 2 equal parts. So this is represented as -1 by 2. Okay, -2 by 2, we will be getting this as -3 by 2. And here you are going to get -5 by 2 and here it's -3 and so on. Now let us represent with one more number on the number line. So let me take that as 3 by 4. So 3 by 4, as you have seen the denominator as 4. Now from 0 to 1, 1 to 2, from one number to the other number, we need to make 4 equal parts. So just see here, children. Just name it as 1, 2 and 3. Okay. 1 minus 1 minus 2 and minus 3. Now we have to make 4 parts. So 4 equal parts. 1, 2, 3, 4. Here also 1, 2, 3, 4. 1, 2, 3, 4. So here also you will be getting 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 2, 3, 4. Okay? 2, 3, 4. From one number to the other number, we need to take 4 equal parts. Now just see here, this becomes now, this becomes now 1 by 4, 2 by 4, 3 by 4, 4 by 4 and so on. Just see here this side, minus 1 by 4, minus 2 by 4, minus 3 by 4 and this will be minus 4 by 4. That is nothing but minus 1. Okay children, now see here where you got 3 by 4. Yes, here it is 3 by 4. So we have represented 3 by 4 on the number line. Next, let us see the standard form of rational numbers. So what are standard form of rational numbers, children? Yeah, just we'll see that the denominator of the rational number should be positive. Okay, and the numerator and denominator should have no common factor other than 1. Okay, just let us see that. The denominator should be a positive integer, and numerator and denominator have no common factor other than 1. Then we can say that such rational numbers are said to be in the standard form. So children, let us take here a number that is minus 45 by 30. Minus 45 by 30. So now, if you see here, just 45 and 30, both numbers are divisible by 5. That means they have common factors. Now you need to reduce it to rational numbers such that there should be no common factor. Like just see here, as we know that they are divisible by 5. Just you see here, 5 6 are 5 9s are, and both 9 and 6 are divisible by what? They are divisible by 3. So 3 2s are 3 3s are. Now if you observe, you got minus 3 by 2. So as per the condition, denominator should be a positive integer. Yes, the denominator is a positive integer. And if you observe the numerator and denominator, that is 3 and 2, there is no common factor. Other than 1. So now you can say that minus 3 by 2 is a standard form of rational number. Suppose children, let us take one more example. That is 7 by minus 8. 7 by minus 8. Now, is this in the standard form? No, it is not in the standard form. Why? Because the denominator has negative integer. But what we told? We told that it should be a positive integer. So children, to make the denominator as a positive integer, you need to multiply with minus 1 to the numerator and also to the denominator. Just see here, 7 into minus 1 by minus 8 into minus 1. So 7 into minus 1 is minus 7 by minus into minus is plus 8 into 1 is 8. Yes children, now you got minus 7 by 8. Now the denominator is a positive integer and there is no common factor between the numerator and denominator other than 1. So now you can say that minus 7 by 8 is a standard form of rational number. Now let us see the comparison of rational numbers. So we have compared the fractions, right children? The same way, just we'll see that. In the comparison of rational numbers, we have comparative of two positive rational numbers, two positive rational numbers, and two negative rational numbers, two negative rational numbers, and the other one is one positive rational number and one negative rational number. One positive and one negative rational number. One negative rational number. So children, already we have seen how to compare two positive rational numbers. Two positive rational numbers are nothing but what? Two fractions. Okay, already we have seen this. Next is two negative rational numbers. Yes, now we need to see the two negative rational numbers. Let us see that after this. One positive and one negative. Children, always remember that the positive rational numbers will be greater than the negative rational numbers. As we have seen in the integers that all positive integers are greater than negative integers. Here also, all the positive rational numbers are greater than negative rational numbers. Okay. Now we will see two negative rational numbers. So let us first compare the two rational numbers. Let us take them. That is children, minus 2 by 3. And we are going to take the other number, that is minus 5 by 2. 5 by 2. So see children, we are going to take these two rational numbers and now we are going to compare them. So for this we need to take the LCM of the denominators. So children, what is the LCM of the denominators? LCM of denominators, LCM of 3 comma 2, that will be equals to 6. So children, make the both the denominators equals to 6. So for that, 2 by 3 minus 2 by 3 into. So in the denominator, what should we multiply to get 6 children? Yeah, it is 2. So the same number should be multiplied to the numerator also. And here if you see minus 5 by 2, here also you have 6. You need to get, so here you have 2. So what you need to multiply to get 6? Yeah, it is 3. So the same number you multiply here also. Then we are going to get over here is minus 4 by 6. And children, here it is minus 15 by 6. As you know that we have already seen in the integers. Okay, integers. Normally just see minus 4 by 6, minus 15 by 6. So keep the denominators aside and just check minus 4 is greater or minus 15 is greater. Yeah, minus 4 is greater. So minus 4 by 6 is greater than minus 15 by 6. That is nothing but minus 2 by 3 is greater than minus 5 by 2. Okay. Now, I think you have understood. So minus 2 by 3 is greater than minus 5 by 2. And this way we can compare the rational numbers. Rational numbers between two rational numbers. So children, here are the two rational numbers. Now we are going to find the rational numbers in between these two rational numbers. So for that, children, you need to take the LCM of both the denominators. So LCM of 5 comma 3 is equals to 15. Now children, make both the denominators equals to 15. So what we will be getting? Minus 3 by 5. So 5, if you multiply 3 to 5, you are going to get 15. The same 3 here also you multiply. And here you have minus 1 by 3 into, now 3 means you need to multiply 5. So just see here, you got minus 9 by 15 and here you got minus 5 by 50. So easily children, in between them what will be there? You have already minus 5 by 15. So in between them we will be having minus 6 by 15, comma, minus 7 by 15 and minus 8 by 15. Now only these three rational numbers are there in between minus 3 by 5 and minus 1 by 3. So let us see. Now as we got that minus 9 by 15 and minus 5 by 15. Now just multiply 2 to it. Multiply 2 to it. So to both the rational numbers, you multiply 2 to the numerator and also to the denominator. Then what you are going to get? Just see children. That will be equals to minus 18 by 30 and minus 10 by 30. Now see here children. In between them what you will be having? Minus 11 by 30, minus 12 by 30, minus 13 by 30, minus 14 by 30, minus 15 by 30 and so on. Okay, and so on. So children, till where you will be getting? Till minus 17 by 30. That means in the middle you will be having minus 16 by 30. So these are the rational numbers are also presenting minus 3 by 5 and minus 1 by 3. So children, here already we got 30, minus 18 by 30 and minus 10 by 30. That even you can multiply it with 5 or with 100. You will be getting many rational numbers in between two rational numbers. That is, infinite rational numbers are there in between two rational numbers. We can find infinite rational numbers. Okay? Thank you. Talla Padmavathi International School.